Hello everyone, this is Sukruti Joshi from LG Institute of Engineering and Technology, Ahmedabad. I am going to take the video lecture series on chemistry. The subject code for chemistry is 311001. In our previous sessions of this particular subject, we have started chapter number 5, that is chapter number 5, which is nanomaterial. In nanomaterial, we have observed the properties of fullerenes as well as of fullerols. Now we will see the applications of it likewise. So here, as you can see, it is widely used in polymer electronics, in antioxidants and making biopharmaceuticals. Likewise, we can use them in making the catalyst, the vehicles, etc. Now, when we talk about the polymer electronics at that time, the performance of polymer transistors and photodetectors has been increasing due to use of the fullerenes. Likewise, if I say here antioxidants and for biopharmaceuticals, the fullerenes are powerful antioxidants reacting readily and at a high rate with free radicals. Fullerenes hold great promise in health and medical sector. Similar way, when we talk about the catalyst, so at that time we need to understand that here the catalysts, which are known as marked ability to accept and to transfer the hydrogen atoms, hydrogenation and hydrogen alkylations. These are the things which are very important, right? Which are very important in any kind of chemical reactions. Here, now let's talk about another one, which is vehicles. So they provide enhanced durability, lower heat buildup, better fuel economy with the use of fullerenes. You need to understand that these are a very common and very vast applications of fullerenes. Now, our next point is properties and applications of metal-based nanoparticles. So if we talk about these properties and applications of metal nanoparticles, here we can take an example of gold, silver, titanium dioxide, etc. Similar way, the term metal nanoparticles used to describe the nano-sized metals with dimensions, width and within the size range of 1 to 100 nanometers. Here, if we talk about the properties of this kind of nanomaterials, so the effect of size on the melting temperature, which is the first and foremost property. So if you want to look here, the melting temperature decreases with the dimensions of metallic nanoparticles. The many surface atoms being less restricted in their thermal motions will fluctuate more easily spatially, thereby lowering the melting temperature. Okay, here let's take a look on another one, which is the chemical reactivity. Now, as the size decreases, the surface area increases, and as the surface area increases, their chemical reactivity also increases. Okay, and another property, that is color and oxidation states. So along with decrease in the size, the color and oxidation states of the metal changes. For an example, gold particles at macro sizes has golden yellow color, while at nano sizes their color changes to the red brown. This is a very common and very important example which we need to consider for. Now, if we talk about the applications of metal-based nanoparticles, so at that time it is used in catalysis. Okay, supercomputers, widely used in supercomputers. So here you need to understand that planar arrays of the uniform metal nanoparticles would allow the design of new supercomputers having the superior, or basically the supercomputers having a superior data storage capacity. It is most important for all of us when we deal with such kind of things. Okay, it also has certain biological applications, like it is used for drug delivery to the particular position only. Electrochemical sensors, the introduction of metal nanoparticles actually enhances their properties. Similar way, we have certain bio-nanosensors, so can enhance the electron transfer between the biomolecules, right? For an example, Ag nanoparticles, which is silver nanoparticles supported on glass used as a selective bio-nanosensors, right? Similar way, water purification. So Ag nanoparticles are widely used in water purification beds. Right? It's very important for their purification. Now let's move ahead to the next one, which is properties and applications of carbon nanotubes. Carbon nanotubes can be divided into two main parts. Number one, SWNTs, which is single-walled nanotubes, and another one which is MWNTs. So it is multi-wall nanotube. Okay, understood it here properly, the types of carbon nanotubes are typically referred to as the single-walled nanotubes or single-walled carbon nanotubes. And similar way, we have multi-walled carbon nanotubes. Okay, there are many variations of both the types. They vary by purity, length and functionality also. So depending upon that, their property changes and their application also changes. Okay, let's take a look on the properties. The first one, which is electrical conductivity. So CNTs can be either metallic or semiconducting in their electrical behavior. Second property is strength and elasticity. So SWNTs, which is single-walled nanotubes, are stiffer than that of the steel and are very resistant to damage from physical forces. MWNTs are considered as the strongest nanomaterials present till date. And similar way, we have thermal conductivity. Okay. Thermal conductivity is basically, they are considered as its capacity. So CNTs are considered as the best heat conducting materials. Okay. Now applications. If we talk about applications, so first application we found in energy storage. In energy storage, if we talk about CNTs have the intrinsic characteristics desired in material used as electrodes. CNT's high strength and toughness to weight characteristics may also prove valuable as a part of composite components in fuel cells. They are used to enhance the properties of such kind of fuel cells. Now, they are used in fabrics and fibers also. So such super strong fibers will have many applications including body and vehicle armor. We can use them in all these things. Now, what is the application of this in biomedical field? So cells have been shown to grow on CNTs, so they appear to have no toxic effect on it. And CNTs are widely used in air and water filtration also. So they are generated, or they are called as carbon nanotube generated air and water filtration. So it has been reported that these filters can not only block the smallest particles but also kill most of the bacteria. So this is another area where CNTs have already been commercialized and are products on the market now. Now let's move ahead to the next one. Our next one is properties and applications of nanowires. Nanowires are almost widely used one and they can be utilized in many ways. First one is a magnetic property. Actually, the magnetic properties of nanowires depend on the wire diameter and aspect ratio. It is possible to control the magnetic properties of the nanowires by controlling the fabrication parameters. Similar way, optical properties. So controlling the flow of optical encoded information with nanometer scale accuracy. This gives us an idea that how it is widely used. Because of their properties only they are widely utilized. Okay. Applications, if we talk about it, and the most important application is in nanoelectronics. They are used as a cross nano devices, multi-segment nanowires, etc. They are used in sensing devices like thermal sensors, are best manufactured from nanowires. Likewise, important components of quantum wire device are silicon nanowire as a channel and silicon as a strange or basically storage node and silicon nano gate as a control gate. Right? Now, we will take a look on certain different types of particular branches of nanotechnology where we actually uses we actually apply the knowledge of basic and nanotechnology together and convert it into a applied branch. So here if you want to look, we have nanoelectronics. So nanoelectronics is based on the application of nanotechnology in the field of electronics and electronic components. Although the term nanoelectronics may generally mean all the electronic components, special attention is given in the case of transistors. These transistors are sizes less than that of the 100 nanometers. Okay. Now let's take a look on the basic principle. So the basic principle is that the power of machine will increase according to the increase in volume, but the amount of friction that the machine's bearing hold will depend upon the surface area of the machine. Okay. Now we will take an approach, that which approaches are used in nanoelectronics. So here if we take a look, first one is a nano fabrication. So it is a method which is used to design arrays or layers of nanoelectronic devices to work for a single operation. Nano electromechanical systems are a part of nano fabrications. Okay. Similar way, nanomaterial electronics. We have to take a look in nanoelectronics. The transistors are packed as arrays onto the single chip and thus they remain in a uniform manner. Right? Now, which are the applications of nanoelectronics actually? So, here nano radio, they are used to produce nano radio, nano computers. The conventional computers with a big processor will be replaced with nanocomputers with nanoprocessors that will give a very high performance and speed than that of the conventional computers. Similar way, we have energy production, right? So how it is used in energy production? So the devices using nanoelectronics technology also include solar cells and that are highly efficient and cheaper than that of the conventional ones. Same way, using the technology, researchers are developing a generator for energy production which is called as bio-nano generators. Okay. Now, let's take a look on the branch where we use the application of nanomaterials in catalysis. Okay. So, nano-bioengineering of enzymes is unable to conversion of cellulose from wood chips, corn stalks or unfertilized perennial grasses into ethanol for fuel. So, what we have to understand, cellulosic nanomaterials are projected to less expensive than many other nanomaterials. So here they increase or are used increasingly in catalysis to boost certain chemical reactions. It gives us very good results as compared to the conventional one. It saves money, it reduces the pollution also. Okay. Now let's take a look on the application of nanomaterials in textile industry. So nanotechnology can provide high durability for fabrics because nanoparticles have a large surface area to volume ratio and high surface energy also. Now let's take a look on examples. So it is used in sporting industry, skincare, space technology, clothing, material technology, which are used in extreme environments, in extreme cold or in extreme hot conditions. Okay. Some interesting examples like we have stain repellent and wrinkle resistant threads woven in textile. Similar way, nano soaks treated with silver nanoparticles, the silver acts against the infection and odor. The properties imparted to textiles using nanotechnology include water repellence, soil resistance, antibacterial, etc. Now, let's see that which are the applications of nanomaterials in medicine. Okay, in medical field, it is basically the application of nanotechnology. So nanomedicine is the application of nanotechnology. For an example, gold nanoparticles as a probes for detection of targeted sequences of nucleic acid. Similar way, it is used for both the diagnosis and treatment purpose. Right? It is widely used in the treatment of atherosclerosis or the buildup of the plaque in arteries. Right? This is a very general and very popular example of it. Nanotechnology researchers are working on a number of different therapeutics where a nanoparticle can encapsulate or otherwise help to deliver the medication directly to the cancer cells and minimize the risk of damage to the healthy tissue. Right? It is possible for us if we move ahead like this. Similar way, research in the use of nanotechnology for regenerative medicine spans several application areas including bone and neural tissue engineering, biomedical engineering. Researchers are also working to create a universal vaccine scaffold for the annual flu vaccine that would cover more strains and require fewer resources to develop each year. So these are the applications of nanotechnology in various fields. We have taken three main fields, but nanotechnology is nowadays used everywhere and it finds its application almost in each and every field. So because it gives us a very good idea, a very better advancements than that of the conventional method, nowadays nanotechnology is used everywhere, from a polymer industry to paint industry, dyeing industry, pharma industry, textile industry, food industry, cosmetics industry, everywhere in one form or in another form, nanotechnology is continuously used. And here in this chapter we have seen that how it is applied and how it is synthesized. This is all for this session. Next we will see in our next sessions. Thank you so much everyone.